I was asked to do a screencast showing the answer to application exercise 4.1, which illustrates the fact that in the presence of monopoly, a price control can actually be welfare enhancing. In this case, because of the dynamic concerns, there's an argument, but if it were a static case, there'd be no doubt that a price ceiling could lead to a welfare increase. All right, let's go ahead and do this then. Notice I've got this demand curve and marginal cost given, and then I'm going to consider a $50 per EpiPen price ceiling. All right, I've written down the given information, or some of it anyway. The key to doing this kind of problem is to realize that the marginal revenue for a monopolist, if we've got a straight line demand curve as we do, is the marginal revenue is just another straight line that has the same y-intercept but is twice as steep, which 2 times 3 is 6. All right, and then our output rule for monopolist is marginal cost equals marginal revenue, and that means that 680 minus 6q is equal to 20. That means 6q is equal to 660, and q is equal to 110. All right, so that is the quantity that the monopolist will produce. We can plug that back into the demand curve. Make sure you plug that into the demand curve, not the marginal revenue or marginal cost. Sometimes you have a function for marginal cost, not just a flat line at 20. All right, so the price is 680 minus 3 times 110, which is 330. 680 minus 330 is 350. That's our price. I've got it graphed on the next slide, but for now, just notice that the profit maximizing quantity is 110, profit maximizing price is 350, and under the price ceiling of $50, we can the marginal revenue function for the monopolist, when there's such a price ceiling, is just a flat line at the price ceiling. So now there isn't a need to pass any discount, and in fact I can't raise my price, so it's just a marginal revenue is just a flat line from quantity equals 0 to quantity equals, turns out, 210. It's just a flat line at 50. That's marginal revenue. So given that that's the case, we can figure out the quantity demanded by plugging 50 in for P in the demand function. So 50 equals 680 minus 3Q, and that means 3Q is equal to 630, and that means Q is equal to 210. So that's enough information to go and graph things up here. And notice what I've done. I've graphed the demand function, the marginal cost function, the marginal revenue function, twice as steep, and then notice that the graphical analog of what I just talked you through is we look for the point where marginal cost and marginal revenue are equal. That happens at 110 1,000 EpiPens a year. Keeping track of that thousands is especially important when we go to look at the deadweight loss of the monopoly outcome. That's at least the portion of the deadweight loss that's eliminated by the price ceiling. Then we take that 110, plug it into the demand curve to get a $350 per dose price. At the price ceiling, the quantity demanded is 210, and I guess I can, let me use a different color. Okay. The marginal revenue function is a flat line at the price ceiling up until 210. I misspoke in class. I had indicated that there was a portion of the marginal revenue curve that after that 210 the marginal revenue curve started like that, but no, actually the marginal revenue curve picks up after 210. It would be the continuation of this line, right? Because they'd have to discount all 210 EpiPens in order to sell one more, and that leads to, whatever this function would be, but way down low. We can off the screen actually. Okay, so then when we calculate the welfare gain, and there is a welfare gain, unlike in the competitive case, the price ceiling can increase welfare. Notice that we picked up a lot more consumer surplus. If we go, the height of that triangle is 300, the width is 100, so 1/2 times base times height, 150 times 100, that's 15,000, but there are 15,000 thousands, right? Notice that this is thousands. So this triangle is 15 million per year. And then there is some producer surplus because $50 is higher than the $20 marginal cost. And that's 100 times 30, another 3 million in surplus. So 15 million plus 3 million, 18 million per year. And notice there still is this teeny dead weight loss triangle, but the way I've constructed this problem, essentially I've assumed that Mylan is a natural monopolist over EpiPen. That might not be true. Remember, they had a competitor, but the competitor did go out of business, which might indicate that there's only room in this market for one producer of EpiPens. If the average cost function looked something like that, this price ceiling would let the monopolist just break even, and this is this would be very similar to it is an average cost price rule in this case for a natural monopolist. So we see a lot of garbage companies, local cable companies, water utilities, etc., regulated this way. And this, there's an argument, at least in a static analysis, for regulating drugs this way, pharmaceuticals this way. Of course, when we consider the fact that patents and the monopoly profits that they result in when a drug company is successful in bringing a drug to market, when we consider that side of things, we realize that allowing a drug maker to break even on a commercially useful drug, that would eliminate the incentive for that drug maker to try to bring blockbuster new drugs to market. And blockbuster, yes, sometimes is Botox, not a huge social gain there, but very often these blockbuster drugs cure some forms of cancer, and so limiting innovation, reducing the incentive to innovate would result in a significant loss of innovation, and that would be a bad thing. We'd have to weigh against the reduction in dead weight loss in just this period. We'd be losing useful drugs for all time potentially. Again, the rejoinder, just to give you a sense of the policy debate, it would be, hey, EpiPen's old technology, there's no new chemical there. We can leave the patent system in place for brand new drugs, but for 50-year-old drugs, why do we have such high barriers to for generics even? Why do we make them go through FDA approval processes that are arguably way more burdensome than any risks associated with the known substances justify? And that's really actually a good argument. You'll be part of that argument going forward, I expect.